Good morning, rather good afternoon to all.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon,
Good
sir.
afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon.
गुड आफ्टरनून सर, कैसे हो?
Good, thank you.
सर आपको आज असाइनमेंट 3 देने की जरूरत नहीं है सर।
यस
आप
सर, प्लीज आज मत देना।
क्या
सर असाइनमेंट 3 आज प्लीज मत दो सर, वीकेंड खराब हो जाएगा प्लीज।
Yes, sir,
केमिस्ट्री का
please.
भी बहुत होमवर्क है
केमिस्ट्री का बहुत होमवर्क है
सर। असाइनमेंट 2 में ही इतना भेजा फ्राई हो गया।
Okay, as you please.
थैंक यू सर।
सर डाउट लेने से पहले ही सॉल्व।
सर को पता है।
हम 1 बोलने ही वाले हैं।
सारे बोलने वाला है। 1 to 14 तो सभी होंगे।
This angle is theta. This angle is
Alpha.
alpha. This is CBA. And this wall is fixed. This is fixed. C cannot move in that particular direction. Right? So I will take acceleration of this to be AY and acceleration of this to be AX. Acceleration of this I will call it AA. Why? Because I know that capital A will travel only in the horizontal direction. Capital A cannot go upwards. This will be coming downward. This will be moving this way. Till here, is it clear?
Yes, sir.
Yes, sir.
They gave you that the acceleration of B is A. So first equation is A is root over of AX square plus AY square. This is my first equation. They have given you acceleration of B is A. Which direction I don't know. So I took A by AX and I took the resultant. I know it is A. But one thing is for sure. Resultant of this acceleration in this direction. If this is theta, this will be theta,
Yes, sir.
Yes.
right? This will be 90 minus theta. So AY cos theta plus AX sin theta is the acceleration of B along the common north in this direction. Agreed?
Yes, sir.
So AY cos theta plus AX sin theta. AX cos 90 minus theta, this should be equal to the acceleration of this. This angle is theta.
Yes, sir.
This will be A sin theta. These both should be equal along the common normal. Along the common normal, these both should be equal. This is A sin theta. This is my second equation. This point, is it clear?
Yes, sir.
Along the common normal, acceleration of B and acceleration of A along the common normal should be the same. Something equally important. If this is AX, this is AY, acceleration in this direction, this is alpha, so this is alpha, right?
Yes, sir.
AY cos alpha minus AX sin alpha, because if this is alpha, this is 90, this is 90 minus alpha.
Yes, sir.
So
Yes,
this
sir.
is AX cos 90 minus alpha. AY cos alpha minus AX sin alpha will be the resultant here. This minus this in this direction. What is acceleration of C? In this direction, AC cos alpha, but AC is 0. So AY cos alpha minus AX sin alpha should be 0 is my third equation. Three equations, three variables. I should not have a difficulty in simplifying them. Undoubtedly, first problem is a tough one. Now that I have solved it, it appears easy. First attempt, anybody they will find it to be difficult.
Yes, sir.
Yes, sir.
Yes, sir. I got confused in the alpha part that I didn't do that part.
That angles will be deceptive for you. Here, when you are taking perpendicular to the inclined plane, I should take alpha and not theta. What students do is, here itself they will resolve it and they take theta there also. It's a mistake. Can I rub the board?
1 second, sir. So 1 second, just 5 seconds. Yes, sir, done.
This is a cylinder.
We did this question yesterday in class.
We did the third one, but second one is similar, so we got it.
Yes, sir. Second one is
Same
similar.
exercise.
Yes, sir.
Fourth question में now there is a tricky catch in this problem. Firstly, let me assume there is no floor here and solve this problem. This is 10 and 8. Firstly, let me assume there is no floor and solve this problem. I'll get this as T, this as T, this will be 2T, this will be 2. Agreed? What will be the tension in this particular string? Coefficient of tension here is 1 into G plus 1 into G plus 2 into G upon 1 square by 5 plus 1 square by 10 plus 2 square by 8. 4G divided by 1 by 5 plus 1 by 10 plus 1 by 2. 4 by 8 is 1 by 2. 4G divided by LCM is 10. 2 plus 1 plus 5. 40G by 8. This will be 5G. If the floor didn't exist, the tension would be 5G in the string. Agreed?
Yes, sir.
Yes, sir.
Now, don't jump to conclusions. Listen carefully. Tension is 5G. This is 10G. Do you think this will move up?
No, sir.
No,
No,
sir.
sir.
So technically, when I have a floor here, 10 kg block is not going to move up. 10 kg block is on the ground because the tension is 5G. But listen, now I cannot solve the problem using 5G because I have another force called normal force here. Don't continue with the problem here. This was to confirm what is happening to 10G. Why are you keen on 10G, not 8G? 8G is lesser. 8G is lesser and there is 2T in the upward direction. So 10 I was worried about. And my worry turned out to be true. It's a well-laid trap. 10 kg block will not move up. 10 kg block will not move up. Some students will tell me that when 5 kg block also should not move because tension is turning out to be 5G. Listen carefully. Now that I have a normal force here, don't you think the tension decreases? I'm trying to lift this mass in the upward direction. Don't you think tension decreases? This tension would be right if all three masses are free to move and there is no normal force acting on them. This tension would have been correct if all three masses are free to move. I first confirmed the tension to verify if the 10 kg block will move or not. First step. Is this clear to all?
Yes, sir.
Yes,
Yes,
sir.
sir.
I have an idea that 10 kg block may be at rest. Even now I may be wrong. I will solve the problem. If normal force turns out to be 0 or negative, that means 10 kg block is moving. I will keep even those doors open. I am not going to be biased. I'll keep all my doors open. Maybe the 10 kg block will move up. I don't know. I'll solve traditionally from the dynamic equation. First, make a note of it. Understand that there is a norm, because first I calculated the tension without the flow. Tension turned out to be 5G, which is lesser than 10G. So I have a feeling now that 10G will not be moving up. But yet, while solving, I will not keep that bias in mind. I'll solve right from scratch. Take this down.
Sir, so sir, if tension is less than the weight, we have to take the normal force.
Naturally, block is kept on the floor. I don't have a force which is lifting the block. So there is normal force between the two.
Yes.
So the apply is less than mg. That means the block is on the floor. So when the block is on the floor, there is a normal force.
Yes. Thank you, sir.
Can I rub the right part of the board?
Yes, sir.
Yes, sir.
Yes, sir.
Now see, traditionally, what will I do? I will take this to be going up with an acceleration of a. This would be going up with an acceleration of, this is a2. I take this to be going down with an acceleration of a1. I may be wrong in any direction. Nothing to worry, problem will take care of itself. Now see the dynamic equation here. T minus 5G, 5G minus T. 5G minus T is 5A1. 5G minus T is 5A1. See the dynamic equation here. N plus T minus 10G is 0. I am assuming this is at rest. I am assuming this is at rest. N plus T is equal to 10G is my equation. If my assumption is wrong, I will get 0 or negative value for N. I am assuming 10 kg block is at rest. If my assumption is wrong, I will get N ka value 0 or negative. Now come to this. 2T minus 8G is 8A2. Third equation. Are you clear till here?
Yes, sir.
Yes, sir.
Yes, sir.
Now, constraint relations. If this is going up, I'll solve using traditional constraints. Technically, you can take 2T into A2 positive minus T into A1 is 0. A1 is equal to 2A2. A1 is equal to 2A2. Now you have three equations and three variables. T is one variable, N is one variable, A2 is one variable. Just out of academic interest, calculate NNC. Can I calculate? Yes, you can calculate. Three equations, three variables. If N turns out to be negative or 0, that means 10 kg block is not on the floor. It is rising. Here N turns out to be positive. That means the body is in contact with the floor. 10 kg block is in contact with the floor. Simplify for all three and verify. Though he asked only for the acceleration, calculate even the normal force. Calculate even the normal force so that you understand that the 10 kg block is on the ground.
So over here, you haven't included the 10 kg block as part of the constraint relation because it will be at rest, right?
Right.
Okay, sir.
Because you didn't take A3 here. A3 don't exist for it. So it is as good as keeping itself at rest.
So, but at this point, it's just an assumption you're making, right?
Right.
Okay,
After
sir.
calculating N, I'll be 100% sure whether the block is at rest or not.
Okay, sir.
Sir, if n comes out to be 0, then also the 10 kg block should be at on the floor, right? It should
Right.
not move
It
up.
is just on floor. That's the limiting value. But
Yes.
that will happen only when tension is 10G.
Okay, sir. Yeah.
It will remain on the ground even after 5 kg is released.
Yes, verify. Calculate NNC. Calculate NNC from here. If n is positive, it's on the ground, it's in contact with the ground.
Sir,
Sir.
today we're taking up only doubts.
Pardon?
Sir, are you going to teach anything today or only doubt lecture? Is there?
Only doubts, only doubts.
Okay, sir.
So also can you send like
Sir, can you explain again what will happen if n equal to 0?
N is equal to 0. You put n plus in the second equation, put n equal to 0.
Yes, sir. T equal to
Tension
10
will
G
be
then.
10G. Body will just be in equilibrium. Tension is equal to 10G.
Okay, sir.
Sir, n is coming to be positive.
Wonderful. That means 10 kg block is on the ground.
Yes.
Yes.
yes, sir.
Yes, sir.
Sir,
Ah.
sir, if the 10 kg block, like the normal force would come as negative or zero, then would it make a difference in the answer?
Yes, if it is 0, I'll have to see. If it is 0, I have no problem. Tension is 10G, problem is over here. But
Yes,
if
sir.
normal force turns out to be negative, implies this is accelerating upwards. Then I will have to redo the problem taking this acceleration as A3. Here I did only with A1, A2, keeping this at rest.
Yes, sir.
Even this equation will change. If I know n turns out to be negative, that means the body is going up. Then what will my equation here be? N plus T minus 10G is 10 into A3.
Yes, sir.
Yes, sir.
Okay, sir.
Done, sir.
So why
Sir,
will
so
n be negative if it's moving up? Shouldn't it be 0?
Tension is greater than 10G.
Okay, right, sir. To balance that equation, you're saying.
Sir, so in every question, do we have to verify the sign of n?
Whenever
Whether
he
it's
gives you ground this way, you
yeah.
have to verify. This is a deadly trap. A very rare trap, but a deadly trap. If they give you ground here, generally they will not give you ground. This is a deadly trap.
Okay, sir. So we'll have to check the sign of n.
Yeah.
Okay,
Sir,
sir.
and the options were
Yes.
also according to the trap.
Yes, you will make by finding out the value of tension removing the ground. Then I will get my first guess. I made a guess that 10 kg block will be on the ground because I have calculated tension. And then I solved. My guess turned out to be right.
Sir, but here they shown the ground, but here also we took only the 10 kg because for 8 kg, 5G is less. So therefore more. So only for 10 we have taken, sir.
Naturally, whichever is heavier mass, I'll verify for that first.
Okay. Yes, sir.
So the N is a reaction force, right? To the
Right. It is the confirmation that the two bodies are in contact. All our mechanics, remember, if I ever ask you to prove that two bodies are in contact, there should be normal force between them. If the 10 kg block is on the ground, there should be normal force between them. That is the confirmation that they are in contact. Now this has an acceleration of 5 meters per second square. I'll take this to be x naught, this to be moving down by y. If this wedge is moving to the right by x naught, this is also moving to the right by x naught. In this direction, it will be 0. This point is not moving vertically. The mass is moving vertically. This is coming down, this is going to the right. Do you agree with that?
Yes, sir.
This is going down, this is going to the right. Always
Yes,
remember
sir.
one thing. If acceleration of none of the masses are given, then you will have to apply dynamic equations and constraints, both. I repeat, ध्यान से सुनो. If acceleration of none of the masses are given, dynamic equations भी apply करना पड़ेंगे आपको, constraints भी apply करना पड़ेगा. एक बॉडी का अगर एक्सेलरेशन दे दिया, so that indirectly they are asking for the constraint, they are asking for the relation between acceleration of this and this. So आपको dynamic equations लिखने की जरूरत नहीं. One body's acceleration is given. You don't need the dynamic equations. Are you getting this point?
Yes, sir.
Yes.
Now listen. Segment 1, segment 2, segment 3, segment 4. You can play with principle of virtual work as well.
Yes,
For
sir.
a change, I'll solve using traditional dynamic equations. Segment 1, upper end, may move horizontally. I don't mind. I want vertical because segment 1 is vertical. Along the vertical direction, this point is 0. This point is plus y. Do you agree with that?
Yes,
Yes,
sir.
sir.
Yes, sir.
So,
Yes, sir.
Segment 2, this end is fixed. This end is approaching the center. Minus x naught.
Minus x. So
Segment 3, 0. Both the ends are fixed. Segment 4, minus x naught should be 0. Y is equal to 2x naught.
is equal to 10.
Ay is equal to 2 times pi. This is 10. That means for the small mass, I have this as ax, this as ay. Ax will be same as that of pi.
Yes.
Now the common normal both should be the same. Ax is 5 meter per second square. Ay is 10 meter per second square. Resultant will not be difficult for you. The small n will have ay this way, ax this way. Only ax and ay is not to be reported. Resultant of ax and ay must be reported.
We can find a relation by principle of virtual work also.
As well, yes.
So, when is your birthday?
Why did you ask?
सर ऐसे ही सर दूसरे सोर्स का पता है तो आपका भी ऐसे सोचा पूछ लेंगे.
11th May.
अरे सर हाउ ओल्ड आर यू?
सर गोपाल सर एक और लैपटॉप देगा सर.
हाँ सर.
सर गोपाल का स्कीम चल रहा है पे जो सर बर्थडे वाला तो सब एड्रेस भेजते हैं और डायरेक्ट लैपटॉप गिफ्ट करते
सर उसमें भी सर हम दोनों का पार्टनरशिप
वही
है
सबके
सर.
यूएस डॉलर्स आपको देगा.
सर आपको दिया है क्या किसी ने फाइनली यूएस डॉलर्स 5 साल बाद?
What?
सर हैज एनीवन गिवन यू बैक द यूएस डॉलर्स आफ्टर 5 years?
No.
सर पूछना चाहिए ना.
हम देंगे अब रुको.
सर शिवांश देगा सर.
सर अगर हम कमाएंगे तो हम देंगे.
सर हम सब
Don't worry, it is earning interest. Once I retire, I'll start collecting.
Okay, sir. Nice. Good idea. Good idea, sir.
Sir, but our partnership is going on.
ये तू मेरा पार्टनर कब से बन गया?
सर वही देखो
कल
ना.
कल के क्लास में बोल रहा था.
सर देखो क्या
सर
करता है
बना
सही।
था सर।
सर बना रहा है देखो आपको।
Finish up the board.
सर
Yes, sir.
Yes, sir.
Now, sixth problem है this is capital M. M1 is 3 kg, M2 is 6 kg. Now he wants capital M to be at rest. If this is T, and this is T, this will be 2T. Yes or no?
Yes, sir.
Yes, sir.
Because the pulley doesn't have mass. So your requirement is 2T should be equal to mg. T is mg by 2. Now what will T be? Instead of solving the dynamic equations, use the shortcut. What is the coefficient of tension here? 1 into G plus here also it is T. 1 into G plus 2 into G upon 1 square by 6 plus 1 square by 3 plus 2 square by M. This was the formula I told to you.
Yes, sir.
You substitute here mg by 2. This will be 4g by 1 by 6 plus 1 by 3 plus 4 by m. There is only one variable in this equation, capital M. Simplify, you get the answer.
done sir.
एक्सक्यूज मी सर। सर अगर दोनों टीम में वेलोसिटी दिया होता तो हम लोग अगर प्रिंसिपल वर्क यूज करते तो हम लोग -2Tm कैपिटल एम करते हैं +2Tm कैपिटल, क्योंकि m तो रेस्ट में।
0 and 2t into this will be 0. Velocity of this is 0.
ओके।
7.
So you did this in class.
Yes sir.
8. Small m, capital. Is the diagram correct?
Yes, sir.
Yes.
what is given here is cap A is given to you. Once again, bottom line is the same. He is giving you acceleration of 1. One of the masses ka acceleration is given. Don't write the dynamic equation. Go by the constraints. This will have a displacement of, say, y in the downward direction. This will have a displacement of x naught. So this will have x naught, this will have x naught, this will have x naught, right? Segment 1, segment 2, segment 3, segment 4. Segment 1 minus x naught, segment 2 minus x naught, segment 3 minus x naught, segment 4 plus y should be equal to 0. Y is equal to 3x naught. Ay is equal to 3 times A. So small m will have Ay equal to 3 times A and Ax is equal to A. This information is important. You don't take the resultant, you are in soup. Common normal, both should have the same acceleration along the common normal. So Ax will be same as that of capital M. Ay is what you calculated. A and 3A ka resultant you will have to take 9A square plus A square. Root over of 10A square will be the resultant acceleration of small m.
Sir, even if the small m was not in contact with capital M, then also we'll have to consider
Problem will
Ax.
not exist at all. Here, the fact that small m is in contact make the problem a consistent problem. If not, small m would be oscillating. Many more dynamics will get involved into it.
Acha, okay, sir.
It has to be in contact.
So you could solve this using principle of virtual work also, right?
Comfortably, you will get this relation.
Yes, sir.
Can I rub the board?
So 1 minute, so just 1 minute. Yes, sir, done.
This is A and B. He gave you acceleration of A to B 15 I cap plus 15 J cap. This is what they has been given.
Yes, sir.
X and Y has been specified. You have no choice. X and Y in the question has been specified. You have no choice. Right? Now, if I take this to be acceleration of B along this direction, both along the common normal, they should be the same. This is 37. This is 53 degrees. You understood how I took this angle?
Yes, sir.
Yes, sir.
AB cos 53 is the acceleration of B along the common normal. Acceleration of A along the common normal will be, this will be 37, this will be 53. Resolve 15 in this direction. 15 cos 53 minus, if this is 37, this is 37, minus 15 cos 37. 15 along this direction is 15 cos 53 minus 15 cos 37. Acceleration of A along this direction is this minus this. 15 cos 53 minus 15 cos 37. Find out acceleration of B is the question asked. You will be able to solve if you know the values of cos 53 and cos 37.
सर ऑप्शन में -5 आया क्या दिया है?
नहीं हो सकता.
So are the options wrong?
What is the answer that you people are getting?
-5.
-5.
Yes.
Sir, -5 I got.
आ रहा है?
Yes, sir.
Yes.
-5 coming.
तो फिर दिक्कत क्या है?
So but then it means that the block is moving towards the left.
Block moving towards the left. Maybe the values are adjusted that way. Not an issue. Acceleration of B अगर -5 आ रहा है, that means the direction taken is wrong. हो भी सकता है because this has this component. That means this has this component. That means technically this may be greater than this. That's why you are getting a negative sign. This may be greater than this. That means technically it's moving this way. You have taken the wrong direction, doesn't mean you'll get the wrong answer. The answer will take care of itself.
Yes, sir.
Then the problem I asked you people not to solve that, but then it's no big deal. Only thing you should know one point of circular motion. The rod is hinged along this. If the rod is hinged along this point, if it is moving this way, the tip will have a velocity perpendicular to the rod. That's the key catch. This is circular motion. If the rod is moving this way, the tip will have a velocity perpendicular to the rod. It is hinged at the lower point. So when it is moving this way, the tip will have a velocity perpendicular to the rod. This is the way the rod is moving. It is hinged here. It's moving this way. Tip will have a velocity perpendicular to the rod. What does that mean? This velocity you gave me as how much? 1 centimeter per second. Velocity of this will be in this direction perpendicular to the rod. This angle is given as 30 degree. Can I resolve this velocity of what is that point A? Velocity of A. If this is 30, this is 90, I should be able to calculate theta. VA cos theta equated to 1 centimeter per second. VA cos theta should be equal to 1 centimeter per second. I will get VA. And why did you equate both? Along the common normal should have the same velocity. If this is 30, this is 90, this is 60, This will be 30, this will be 60. So VA cos 60 is 1 centimeter per second. Find VA. The only additional information which you need to solve this is the tip will be moving perpendicular to the length of the rod. That VA resolved along this direction and equated it to the wedge.
So in this question, will we imagine a man holding the free end of the rope like we did in the previous assignment, question 457?
Right.
Okay, sir.
Now here this man is pulling this with a force of F. The string will pull him with a force of F. Every action is an equal and opposite reaction. Always remember, if a man is pulling a string with a force of F, string will pull him with an equal force.
Yes, sir.
Man is pulling with the force of F, string will pull him with an equal force. So the tension in the string will be equal to the force applied.
Yes, sir.
Tension in the string. Every action has an equal and opposite reaction. If the man pulls with the force of F, tension in the string will be F. This will be 2F. This will be 2F. And this force you gave me as 1 Newton. Am I right? So what will be the acceleration of this? This will be 3F divided by 3 kg. This is 1 meter per second square. Similarly, this will be 2F divided by acceleration will
So
be
they'll both go in the same direction.
1 meter per second square. Both are moving in the opposite direction. This is moving to the right, this is moving to the left.
Yes, sir.
This acceleration is 1 meter per second square. This is 1 meter per second square because this is 3 times F by 3.
No, but if they move in the same direction, then by principle of virtual work, like both of them will be positive, right? And then that won't be equal to 0. So they have to be in opposite direction.
Both are moving in opposite direction. Make life simple. Why do you make it complicated?
Okay, sir.
Right? Now this T and this displacement are in the same direction. Cos 0 is 1. This T and this displacement are in same direction. Cos 0 is 1. Right? Now, principle of virtual work. This man is pulling in this direction, force, or let me solve using regular constraints for a change. I take this to be moving towards the right by x1, this towards the left by x2, and this by a distance of x. Segment 1, segment 2, segment 3, segment 4. Segment 1, this is minus x1, minus x2. Segment 2, minus x1, minus x2. Segment 3, minus x1, minus x2. Segment 4, minus x2 plus x0. Should be 0. Plus x0 because it is moving away from the center of the segment. 1, 2, 3. x0 is equal to 3x1. 1, 2, 3, 4 plus 4x2. x0 or a0 is equal to 3 times a1 plus 4 times a2. Both are 1. 7 meter per second square.
Sir, done.
12. You're pulling with a force of F, the tension will be F. Small m, capital M. You're pulling with a force of F. So the tension in the string will be F. This will be F cos theta. This will be F. 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 You pull a string with a force of F, string will pull you with an equal and opposite reaction. Newton's third law. Right? Now listen. These both forces, are they acting on capital M?
Sorry, sir.
These both forces, are they acting on capital M?
Yes.
Yes,
Yes,
sir.
sir.
So they both will cancel out each other.
Yes.
Yes.
These both forces are acting on capital M, they will cancel out each other.
Yes, sir.
Yes, sir.
Net unbalanced force on capital M is F minus F cos theta is equal to capital M into capital A. F into 1 minus cos theta by capital M.
So only because the pulley is attached to the block, they are exerting a force on it.
Right? When a pulley is attached to the block, whatever is the tension or the force on the pulley, it will be acting on the block. All forces on the pulley will be acting on the block.
So why is it minus F cos theta?
Both are in opposite direction. F and F cos theta are they in the same direction. This F and F cos theta.
So and won't the force have a y component?
Take the y component if it is of any use for you. Is the block moving vertically? So draw mg as well, normal force as well, all forces were balanced out. Capital M is at rest in the vertical direction. So I'm least interested in the vertical forces. Actually, these forces are also I'm not interested in. Can I rub the board?
Yes.
Yes, sir.
$13. The problem in 13 is the language. It appears very deceptive. This angle is 30 degrees. He should have clearly told you to make your life simple. What should be the acceleration of this wedge inclined surface to which the frame can be moved in horizontal direction towards right, cos is A naught, so that it loses contact here. If he would have told you that, many of you would have solved. The language is slightly deceptive. He says, heavy spherical ball constraint to move the inclined surface is more, determine the maximum acceleration with which the frame can move in horizontal direction towards the right without causing the ball to leave the frame. This is the frame. But this will be confusing for you people. I'll make the question simple. Question is, what is the maximum acceleration so that it loses contact here? If it should lose contact here, this normal force should become 0. I have an mg force this way. I have a pseudo force of me naught. I have a normal force of n this way. This normal force here should become 0. This will be in contact. Now have a look. This angle is theta. N cos theta will be equal to mg. N sin theta will be equal to m in a naught. N sin theta is m a naught. Divide both. A naught is equal to g tan theta. Substitute theta and verify. You didn't take n here. You made this normal force 0. If you made the normal force 0, what does that mean?
They are not in contact anymore.
They are contact.
This is the minimum acceleration for which it will lose contact. You give further acceleration, this will move up. Here right now the body is in equilibrium without this force. You further make it move with a greater acceleration, this will start moving upwards.
So why is n cos theta equal to mg? Won't it move down?
Down, how will it move? यार नीचे कैसा
So
है?
if the frame goes towards the right.
Frame goes toward the right. नीचे कैसा आएगा? It is at the lowest point. इससे नीचे आना है तो the ball should swing. Sides तो देखो.
So that wedge constraint and the block, they are connected right at the bottom.
These both are the same. Both.
Sir, is that MAO the pseudo force that you have applied, or it just
Yes, sir.
like
Pseudo force.
pseudo force? Yes, sir.
So that whole structure is one thing.
Yeah, this whole is one structure.
Yes, sir. Done.
Protein. This is M. This is 2M. Tension here is T. This will be T. This will be 2T. This will be 4T. What will be the value of tension? What is the net coefficient of tension on this?
0.
0 into G plus what is the coefficient of tension here? 4 into G upon 0 square by M plus 4 square by 2M. I'll get 4G by 16 by 2. Square. Mg by 2 is the value of tension that I'm getting. If tension is mg by 2, how much is 4t? How much is 4t?
2 mg.
2 mg. What is the weight? 2 mg. Don't you think acceleration of this is 0?
Yes, sir.
और रही इस ब्लॉक की कहानी, upward tension downward tension cancel हो गया, there is only mg acting on it, so acceleration will be g in the downward direction, इसका acceleration will be 0.
सर आप सॉल्व करवाते तो ऐसा लगता है बहुत ही सिंपल है, खुद सॉल्व करते वक्त
Yes, sir.
For anyone, that's the story. The best way to get rid of a problem is to solve it. Once you solve it, it becomes easy. First time when you're solving it, it's tough. But understand one thing, that's growth. You spent half an hour on a problem, let us assume. You tried by one way, you tried by one way, you tried by one way. You know now 10 wrong ways of approaching a problem. That means you eliminated 10 procedures.
यस
आपका मेथड है ये तो.
So you have grown. Now this elimination of wrong procedures is growth for a person.
यस
Sir,
That
in
is-
some sums, you can also reverse engineer the method by looking at the answer.
See, that's the choice of growth. Life is all about the choice that you make. मुझे आंसर नहीं देखना है.
सर कल तो मैं और आर्यमन ऐसे वो 12th सम पे हम लोग रैंडम साइंस बना रहे थे और फिर तुक्के से आंसर आ गया, तो फिर हम लोग ने वो वाला मेथड करेक्ट मेथड ले लिया और वही करेक्ट था.
12th is easier. 12th should have been difficult.
I know, sir, we were just solving it together and then
Okay. Can I rub the board?
यस सर.
15, I think is the easiest problem in this.
यस
Yes,
सर.
sir.
Yes, sir.
Yes, sir.
You
Did
did
you
it
Yeah,
twice
yeah.
also, so many
Yeah.
times.
submit
हाँ
करो
सर
चलेगा.
सी
It will be V2. This is theta 2. This is theta 2. V2 cos theta 2. Theta 1. This is V1. Theta 1. V1 cos theta. minus V1 cos theta 1 plus V2 cos theta 2 should be 0.
ये सबसे इजी था.
Yes, sir.
Yes, so ये बहुत easy था.
सर पेन
ये
घुमाने
sums
की
थोड़े easy
जरूरत नहीं पड़ी.
तो 14 सम के बाद सब कुछ सिंपल.
हाँ सर.
सर नोस इज मिसिंग.
सर आपका स्माइली चेंज नहीं किया सर पहले क्लास से अब तक.
सर 14 तक आंसू आ रहे
सर
थे.
आई ड्रॉप
क्या
भी
करें?
सर 4 तक आई ड्रॉप्स आ रहे थे. 14 तक आई ड्रॉप्स आ रहे थे.
Both laughing and smiling at the same time. So जैसे वो बहुत ऊपर और जा रहा था और नीचे जा रहा था.
पलका मंकी ऊपर नीचे.
16th किसी को डाउट है?
नो
नो
सर.
सर.
17,
नो सर.
No, sir.
18,
नो
No,
सर.
sir.
No,
No, sir.
18th no doubt.
नो
सर
सर.
No,
एक
sir.
डाउट है सर.
सर किया बहुत टाइम किया फिर आया.
Yes, sir. We got 18.
Hey, 18th is easy. This is capital M, this is small m. Atwood's machine solve करोगे तो टेंशन कितना आएगा? 2m1 m2 m1 m2 g by m1 plus m2. This is what we simplified.
Yes, sir.
Yes, sir.
Yes,
This is
sir.
the answer. First thing that we dealt with an Atwood's machine, simple pulley.
Yes, sir.
Acceleration and tension calculate किया. Now he is telling you small m is much smaller than capital M.
तो
So
इसको
that means denominator you can neglect small m. Tension will be 2 capital M small mg upon capital M. This will be 2 mg. So here tension will be 2t. This will be 4 mg.
सर ये कैलकुलस के फर्स्ट क्लास की याद दिलाता है सर जब लाइफ बहुत सिंपल था.
हाँ सर क्या लाइफ था वो.
लिमिट x to 0 और फिर डायरेक्टली.
मगर याद करो when calculus was being done area of a sphere ये सब जब कैलकुलेट कर रहे थे इंटीग्रेशन बाय सब्स्टिट्यूशन कर रहे थे तब पसीने छूट रहे थे. यस सर.
हाँ सर.
Yes, sir.
पहली बार करे थे तभी. उसके बाद
वेक्टर्स जब सीखे डॉट प्रोडक्ट क्रॉस प्रोडक्ट एवरीथिंग विल अपीयर स्ट्रेन. कल
Yes,
तक
sir.
2 into 2 was 4. टुडे यू आर आस्किंग मी डॉट प्रोडक्ट एंड क्रॉस प्रोडक्ट.
Yes,
अभी भी पसीने छूट रहे थे. काइनेमेटिक्स का सेकंड असाइनमेंट देख के पसीने छूट रहे थे.
हाँ
बट नाउ
सर
यू
वो
हैव
याद
ग्रोन
मत
ओवर द
दिलाओ.
टाइम.
Yes, sir. Yes, sir.
This is growth. Over the time when you turn back, those should appear to be easy. Remember this word of mine. By the time we finish another 2 chapters, Newton's laws will be much easier.
सर एक महीने में ये भी असाइनमेंट इजी हो जाएगा.
हाँ
थोड़ा.
सर पढ़ के थोड़ा आ जाएगा ना.
सर आप होमवर्क दोगे क्या आज?
सर प्लीज नहीं.
मैं तो तैयार हूँ 2-2 असाइनमेंट्स के साथ.
सर
No, sir.
हमने
इसीलिए पूछ रही हूँ सर
होमवर्क
होमवर्क
के साथ
दोगे
बात
क्या?
की हमने.
ओके
सर
ओके.
थैंक यू.
भेज दो पर डिस्कस जल्दी मत.
सर एक भेज दो फिर.
हाँ
मंडे को भेजो ना.
सर मंडे को भेज
देखो
दो.
प्लीज प्लीज
सर
सर.
मंडे को भेज दो फिर हम लोग कर देंगे मंडे को. सर
Monday का
मंडे को
window.
दोनों भेज दो लेकिन ये वीकेंड रहने दो सर प्लीज.
वीकेंड का एक दिन बाकी है. कल
वोटिंग करो आप लोग. वोटिंग करो. Listen, people who want the assignment today, raise your hands. People who want the assignment today, raise your hands.
सर आपकी भी चॉइस है.
हाँ सर.
सर मेजोरिटी साइज मत दो सर. हम लोग जीत गए.
13 students want. बाकी सब no. इतना थक गए आप लोग. Okay, have rest. I'm
थैंक्स
okay
सर.
with it.
पूरा हफ्ता
Learning should be a happy process. I
Yes,
don't
sir.
force it, right? I am.
सर एक साथ दो देते तो टीडियस प्रोसेस बन जाता है.
हाँ ना.
It's okay. I'll discuss next week. Don't worry. I'll not stretch the syllabus ahead. I'll wait
Thank you,
to
sir.
complete the assignment, discuss, and I'll go ahead. Ultimately, you should do the assignment, not me.
कर देंगे सर हम लोग.
Yes, sir.
Right?
चलो.
19th, technically speaking, is kinematics. SC equal to half AT square.
सर इसमें कुछ था ही नहीं न्यूटन
Yes,
लॉस का.
sir, this is
इसलिए
the
तो बस
easiest
डायरेक्टली
problem.
रिजॉल्व करो हो जाएगा.
19th is pure kinematics. Half L is equal to half AT square. A will be G. L is equal to half G sin theta into T square. Same L is equal to half G sin 2 theta into T naught square. Divide both, that's 90. 20th तो आ गया होगा आपको. Monkey
हाँ,
climbing
sir.
up.
हाँ सर.
Monkey climbing up. 20th किसी को डाउट है? Good Grace. Good to see you people sailing through this. For your information, अगर आपने assignment sheet ढंग से देखा हुआ होगा तो ऊपर date देख लो. This was for your senior batch assignment sheet.
Yes, sir.
We saw.
Sir, अभी तो confidence आ गया.
For them, this was given after we finished Newton's laws, just before they were supposed to take the topic-wise test.
Oh damn.
So this is a tougher one, right?
Let's go, sir. अभी
Yes,
तो
sir.
अच्छा लग रहा है, sir.
Yes, sir, confidence बढ़ गया sir अभी.
आगे के दो इसके जैसी है कि
Sir,
इससे
sir.
easy
Tough
है
है
क्या?
sir, बहुत tough है.
आगे के दो भी are based on the same lines as that of this. They will be as difficult as this or slightly more difficult than this.
Okay.
Next
Sir.
assignment 3 will be for sure tough. 4 will be slightly easier.
Okay, sir.
Sir,
Looking
so it
forward.
will be like
The
the
three will
physics
have-
का graph which you have shown.
हाँ sir.
जो भी है.
The three will have wedge constraint and stick constraints together, right?
Sir. Sir, आज का recording भेज सकते हो?
भेज सकता हूँ.
हाँ
Thank you,
सर
sir.
भेज दो ना.
हाँ सर, ये
Sir,
recording भेज देना, बहुत काम का
या
है.
अपलोड कर दूंगा.
Thank you, sir.
हाँ,
Thank
sir.
you,
Thank
sir.
Thank you.
Sir, Gaurav sir.
लास्ट
is-
क्लास में आपने वो एटवुड्स पुली कराया था जिसपे एक ब्लॉक को मोमेंटरीली स्टॉप करते हैं. So when we stop the block momentarily, will the rope get bent or it will remain a single straight rope only, but it won't be tense anymore?
Momentarily, when you stop, tension in the rope will become zero. It may not fold.
Okay, sir.
It may not fold, but tension will become zero. Today's lecture, I'll upload it on the YouTube. Okay.
Thank you, sir.
See you people on Monday. Wish you all a happy weekend.
Thank you, sir.
You too, sir.
Thank
Bye.
you, sir.
Bye, sir.